Yeah, I'll just turn off my video there, turn it on here. Yeah. So I'll start with the very basic. Okay, start with the very basic. We will maybe just mention what is a sequence. Okay? Sequence. So Nandini, do you know what is a sequence? What is a sequence for you if you have heard this term? Okay, so both of you have said that it's a collection of numbers, but is it not more than just a collection of numbers? So let me ask both of you. So if you look at, so first I'm remarking about the word collection because it seems to have been common both of you. So if I give you, let's say, this sequence, this, and then I give you another collection, if you want to call it that. Yeah. So my question is, would you call these two sequence? First of all, do you agree that both of them are sequences? Hello? Yes, right? So both of them are sequences. Now, are these different sequences or same? So I mean, just according to the standard notion, different. So Satya, you're saying they're different. Nandini, you're also saying it's different. They're different. Am I correct? Is there some connection problem? I'm not able to hear. Hmm. Okay. So is my voice clear? Okay. Okay. So clearly these are different, right? Now, if these are different, then you cannot use the word collection, right? These are different. So why are they different? Because the terms are in different orders, right? So a sequence would not just be a collection of numbers, right? A collection would mean just a collection where uh, there is no notion of which comes first and which comes later and so on, right? It's just a bag of numbers, a bag of whatever, right? But this is a sequence, which means that it's a list of numbers. You could call it so. We want to say, we want to express that the order matters. Is that right? And now to express that, you can call it a list, you can call it an ordered list if you want to be more precise or whatever. But you must understand, which both of you do, right? But you have not said it while expressing it, right? That it is a list of numbers. It's a ordered list of numbers, or you can just say that it's a collection of numbers where the order matters. All of them are of same things, right? So it's just a list of numbers. I'll just write it in the simplest way. So a list. So is that slight distinction clear? Okay, good. So now to the second point of right. So again, both of you have said something like there is a pattern. Okay, there is a pattern in them and so on. But again, think again, is it necessary for there to be a pattern among the numbers? Is a pattern, so we are doing this very basic thing now, just trying to understand this concept. Okay, is a pattern necessary to, for the list to qualify as a sequence? What do you think? I mean, if you, yeah, okay, right. So, Nandini, what do you think? Do you think a pattern is necessary for it to qualify to be called a sequence? Right. Okay. So, in the standard agreement that mathematicians make, or its standard, is that a pattern is not necessary. Okay. Well, if you think about it, the word pattern itself is not a very precise word. What is a pattern? How you could say, okay, that arithmetic progression, if you know what that is, it's a pattern. You could say that, yeah, the next number should be divisible by this, that's a pattern. But then there could be some other pattern. How do you know? You can never just say that something, that these are all the possible patterns, right? So the word pattern itself is not a very precise word. So a pattern is not necessary. It is true, however, that yes, most of the meme sequences you look at, maybe they will have some patterns. So the challenge would be to find a pattern somehow, right? I mean, whether there is a pattern or not depends on how good you are at looking at patterns, or at calling something a pattern in certain. Anyways, but it comes down to the fact that, I mean, officially speaking, pattern is not necessary. Okay? But yes, you will come across mostly sequences which will have some patterns, maybe. Okay. So I see that's out of the way. This basic thing is out of the way. Okay. Now let me again we'll do the very basics. So let me begin with a sequence and ask if there is ask for a pattern. Okay. Before that, some notation. Okay, just a little bit of a notation, because once again, it's all the game of so what do you call it? I mean, it is all the game of language, right? How you write things and so on is the whole thing. And so notation, right? So notation would be, I mean, so I will just say that nth term, because the sequence has, its terms after terms, right? There would be nth term. So the nth term is denoted will be denoted by, so we will denote the nth term by a of n. A and n is in the subscript. This is just a notation so that we don't have to always say nth term, nth term. It just gets cumbersome to write. Okay, it's the notation. Now here is a very simple example. Yeah, I suppose the pattern is, so what is the pattern in this? Right, it's +4. So that is that's trivial, sort of. But now the main point here is to you all see the pattern, that is okay. Can you write the pattern in terms of an equation? Saying something is one thing, right? But putting it mathematically, and I'm making a precise question in the sense that can you write the pattern as an equation? So maybe it's wrong to say that this is a precise question. I suppose this is also vague, but let's see what you can make out of it. And using the nth term sort of, right? How does the nth term depend on the n minus 1th term? That I want you to write as an equation. Now you can say it's just +4, right? But can you write it as an equation? It should not. One plus. No, that's right. I mean, that is using some formula, right? I don't want a formula. I want to write the pattern as an equation. Yeah, I mean, you're correct. That will certainly do the job. You find the term. But yeah, so what you're saying is that, uh-huh. Yes. So this is, so what Satya said is also correct. What you're saying is also correct. Both are correct answers. So this would be what we call officially a recurrence. Now it's quite useless in this situation in the sense that it is correct. And this is what I wanted. But it's not very useful because we already have a direct formula, and which is very easy to find, right? So as Satya said, that it's sort of a, you take one, you take the first term, and then you're taking n steps, right? So you'll take n minus one more steps, right? Your first step already gives you just one. So you take n minus one more steps of length, each of length 4. So, I mean, this is the simple direct formula, right? So Nandini, do you agree with this formula? Do you know it from before, or that doesn't matter to me. Do you see it now, whether it is important, why it should be correct? That is the, okay. Right? And you can obviously match it. It's correct. If you could put n equal to 2, it's 5. If you put n equal to 3, it's 9. That's okay. But also to understand how this is coming, right? This is the first term and n terms, and this is n minus 1 more steps, and each of 4. So you're adding 4 that many times. That's formula standard. It's a standard formula also, but I just want to see it directly. So this is obviously good enough. It's much better than this. But we are not interested in this kind of thing right now for reasons you will understand. This is what we are interested in. It's a recurrence. We would like to put the nth term, connect the nth term in the using the previous terms. Is that right? And maybe we'll spend a bit of time just getting, just before we do the more interesting stuff, okay, in the sense of we will have some question word problem, and you sort of have to bring out the equation somehow. I'll just be writing some sequences, and you will have to build this kind of equation, which is now recurrence. Okay. So a recurrence is simply something that, you use this previous step or previous steps if you need to build the nth step. Okay. The growth, you have to understand how the growth happens. So let's move on. Let me give you another sequence. So now a new sequence is coming, and you will have to. So I'll just say write a recurrence, but you know what I'm asking for. And at this point, if anything is not clear, like you don't know what I'm asking, then you should first ask that, then think. So I'll just drink some water and come. Keep trying. This is the what you try in the class on stage, sort of, right? In the mom, it's very important. Try this, right? So connect an using an minus 1, an minus 2, and write that sort of equation. Okay. So just see. Okay. Yes. So you say A sub n is equal to A sub n minus 1 plus 2 to the power of n minus 2 minus 1. Ah, nice. Now let us see. Okay. So let us look at what Satya has done first. So here you are just noticing that like I had the 3, this is A2, right? And then to get A3, I have just taken, you just take A2 and you add 2 to the power 1, right? So the 5 is just, you look at, sorry, you look at this and then you add 2 to the power 1. Right. And so at each step, basically a power of 2 is being added, right? And what power of 2 is clear. So, Nandini, do you agree that this is a correct recurrence? Okay, so this is correct. Now let us come to your recurrence. Okay? And obviously, if you put and check, it works. So that is the perspective from which Satya is seeing this. So that's a good, this is good. Now let us come to this. So, Satya, can you try to explain this recurrence, whether it is correct or not? What do you think about this? Sorry, can you explain that again? Uh, yes, it does seem to work for the sequence, but more something more you could try to explain. Okay, so Nandini, can you explain this recurrence? Hmm. Right. So that is the way you are seeing it, and this is also correct. So what do we see? I mean, we kind of see, I mean, at least that's what it looks like so far, that we have two different recurrences. So far, there are two different recurrences, and both seem to follow the same pattern. Okay, so that's okay. That works. Right? So you just double the previous one, but then you subtract the one. Huh? Is fine. So both. So Satya has also explained the same thing. Like it seems to work for the sequence. That's all you can say, because I mean, as a sequence is just given like that, first few terms. Okay, good. Now, obviously, we learn something from here. That's okay. But I mean, is there a way to go from one recurrence to the other? If both are correct, can we jump, let's say, from the first recurrence to the second somehow? Is that something that can be done? Can we somehow manipulate the first recurrence and, sorry, get to the next one, get to the second one? Okay. So far that looks a bit difficult, right? Yeah. So anyways, we'll Maybe see that at some point later. Yeah. But both the recurrences are correct. All right. So let's do one more recurrence. Okay, let's see. So far we have these things. Let me know. So let me come back to this and ask a question. Because at this right time, find a formula for an using the recurrence. Any of the recurrence, both are correct. So find a formula. Find a formula means like a more, I'm not trying to define it and so on, but just a more direct answer. Okay. If it's using the recurrence, you may have a guess with you, that's okay. But can you use the recurrence and formula using the recurrence? So it's sort of like, even if you forget this, only from the recurrence can you find a formula. That is the question. Let's see. So both the recurrences are there. It's up to you which one to use. Hmm. So just like, in the last question, we had sort of a formula that the nth term was, just the first term plus 4 times, that was the difference, common difference, plus n. This was like a direct form. Do we have a direct formula for this question? How do you, yes, what is that? Okay. You mean in your recurrence? Uh-huh. N minus 1 or a of n minus 1. Uh, uh, Sorry, this I think I'm not writing it correctly. Is this correct? Uh, uh, I Sorry, I didn't understand. So when you, yeah, I think you're almost there. So I mean, what Satya is saying from your recurrence, it's almost there. So what you can, this one way. I mean, there are many ways maybe, but what I'm just suggesting is that if you subtract one from both sides, then you can write it like this. Is this what you were saying? I don't know. Can you tell me? Sort of, yeah. Because when you subtract one from both sides, then this just fits. That's the point. Is just seems correct, right? Seems good, not just correct. It's correct, but yeah. Now from here you can again. So okay, so let me see. So what can we do from here? So maybe Satya, you can also try to prove your claim from here. I mean, I know it's so that is your claim, right? That an is 2 to the power n, 2 to the power n minus 1, or no, minus 1 plus 1. Yeah. Yeah. So how do you get this from, let's say, this now from this step, let's say? It's sort of close, or it's almost the same thing. Like the geometric thing you're looking for, the common ratio thing is coming, right? So here, let me give a step. Or no, let's just think. I mean, just think. This should not rush the thing. Okay. How do you explain that? That pattern is clear that it is 2 to the n minus 1 plus 1 that you can see in the sequence also. But I want us to be able to not just see, but also show from the recurrence. I mean, see, I'll tell you one thing. If you're given this recurrence or that first recurrence, you can work out the first few terms like, okay, A1 is 2. Using that, you can work out the first few terms and you can again see the pattern and you can make this claim. But we want to also prove it that it is actually, mathematically, we arrive at it. We want to say that. Okay. So, let's see. Yes. Yeah. Yes, that's right. For any n. Hmm. So, any ideas? No, one can try to use induction. That is, but will not do that. This is a recurrence class. Let's try to do it more by recurrences. So let me give you a small maybe suggestion. So what I'm just saying is that, I mean, just by the way you have this, by the same token, let me write it separately. By the same idea, not just it's just the same thing. You get that a of n minus 1 when you subtract 1 from there, it is this. Can you use this? It's correct, right? If for n it connects with n minus 1 like that, with n minus 1 it would connect with n minus 2 like that, because it's just for any n. So n minus 1 is also some n, right? Can you use that? No. I mean, let's see. So if you use this, yeah, in this, you replace this an minus 1, this thing. That is the thing, right? You just keep replacing it. So what do you get? In this, n minus 1, you get 2 times, you had 2 times, right? Now you again replace it by 2 times n minus 2 minus 1, right? So it's like 2 square times n minus 2 minus 1. Is that right? I mean, do you agree with this, both of you? Yeah. Okay. You can see it in any way. I mean, you could see that it just I'm replacing this thing by this, and it just fits. So now can you use this idea? So an now connects with an minus 2, and we have the 2 squared. So how would you continue this idea? Yeah. So, well, I mean, I could do the same thing, right? I could replace an minus 2 minus 1 by 2 times an minus 3 minus 1, and I'll get a 2 cube. Now, where will this end? If you agree with the pattern, and not just, I mean, you could see that it is really what will happen, right? You can do n minus 4 minus 1. Again, you get an extra 2 factor. Yeah. Then where will this end finally? So is it a bit confusing, or so it seems like maybe it's a bit confusing, right? So let me try a slightly different simplified. I mean, just not simplified, but just easing the notation a little bit. What I'm suggesting is, see, once you see this kind of thing, you see that really this an is not so good, but an minus 1 connects with an minus 1 minus 1, right? Sort of. So what we will do is we will say, okay, we will use a new name, which will help us to talk about things more easily. So since we are doing this recurrence now, I mean, let's just call an minus 1 equal to bn. What does this mean? This just means that we are just calling an minus 1 bn, and for any n. So a1 minus 1 is b1, a2 minus 1 is b2. Just a new name, right? So under that new name, what does this equation become? Can anyone tell you? Anyone of you tell me? Under this new name of bn, how would you represent this equation? If you want to use bn and not ans, then how would you do it? Is equal to 2bn minus 1. Yeah, I think you said it, but I don't know what is happening today. I don't know if is my voice clear? Is my internet bad? I don't understand what is happening. Yeah, maybe my internet is not good. Yeah, now I don't want to change the connection. Is my voice clear now? Is it fine? Okay, then yeah, then it's okay, but I'll just make some changes. Maybe I'll turn off my video for now. Yeah. I could change the connection, but then the Zoom would get shut down as the Zoom will close, and then I can have to. Yeah. It will be a little. Yeah, so basically, it becomes more smooth in the sense it becomes more standard if you use this notation. Okay, now can you tell me what is Bn? I mean, uh, explicitly. Yeah. Now can you give a formula for Bn? So Bn has that very simple equation, right? Bn is 2 times Bn minus 1, 2 times the previous one. So what will Bn be? No, so say that again. Uh, 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 yeah, it's not clear. This internet, I'm just changing the connection. 1 minute. Yeah, so today only all these problems are coming. 1 second, huh? So I don't know, it's strange. Some days it's perfect, some days. Let me see. So now I've changed the connection. Yeah. Yeah. So basically, so Nandini, can you please repeat once again? Sorry. About the Bn. So what will Bn be? Minus 1 will be separate. Oh, no, but I don't see how that comes. Does that come? I mean, see, the Bn minus 1 is 2 times Bn minus 2, right? So it becomes 2 square. Is that right? Huh? The Bn minus 1 is 2 times Bn minus 2. So we get this. And this is 2 square. But the Bn minus 2 is 2 times Bn minus 3. Right? So I will not get a extra plus 1 anywhere so far. I don't seem to get an extra plus 1 anywhere. Right? So what will be the final formula for Bn is what I'm asking. If you continue like this, what will be the final formula for Bn? Well, if you do this, if you keep doing this, so what do you get? You get B4, Bn minus 4. Then where will this go? Well, this will go all the way to 2 to the power something times B1. What will that power be? Uh, yes? Yes, that's perfect. I mean, that's what it is, right? This is what a geometry progression also is. But then that's it, right? So when you write it like this, when it's basically that it becomes double of the previous step. So it just doubles at each step, right? So this is what we expect, and we get it directly from this. This kind of thing is called iteration, right? You apply the same thing. One has to just notice that n is flexible. You could change the n to anything, and that's the key. So when it's n minus 1, this formula becomes for just the previous of n minus 1, so it's n minus 2, and then previous, right? Very, very simple, right? So basically, we get this formula for Bn. Okay, can anyone tell me what is B1? What is B1? B1, come on. So so A1 is 2. So what should B1 be? Right. I mean, it is just because, see, the point is that this is true for all n. That's what you have to realize. That's the thing. And then B1 is just 1. This is just 1. So then we get a very clean formula, right? That it is 2 to the power n minus 1. Okay. So that is fine. Yeah. That's the thing. And let me erase these things now and just write this. Final thing. See, I'm going very slowly, but I am doing this because I want you guys to do the workout more things on your own. Like even if this very small thing, but you work it out on your own, then me writing it and telling you agree. Once I write, then you maybe agree. That's okay. But can you write it on your own? That's the more important thing. So the BN is this. Now the question is, what is AN? From here, what do you get as AN? So we have defined. Mhm. Right, because Bn is because we know the definition of Bn, right? Bn is this. And so then An is, as you said, that's it. So yeah, we just did some natural things, some things, and we got here. Okay, right? Okay. Now let us, yeah, so you guys have to do a lot of practice. So this is the thing of these simple things, okay? But you have to just get that confidence of just, okay, let me write and see what it comes. Because once you write and carry out the steps, it will mostly come because these are just exercise. This is not a really, it doesn't, it's not much about creativity here in this particular place where we are right now. In the sense, it's more about you have to just be able to have the confidence to keep working out the steps. Okay. You can see it's more like that. Okay. Let's move on then. So we have been able to solve this recurrence and form the recurrence and the solve the recurrence. Maybe we should do more of this. So yeah, rather than me saying something new today, let's do a bit more on this. So now I have two things. Should I tell you to form the recurrence or yeah, let's try to do that. Let's see how you can handle it. Yeah. So, and so on. So can you find maybe there are one more. Can you find the recurrence? Yeah, find the recurrence. Or I should rather say construct a recurrence, but so this one is also a standard example. So what I can just say is that think something simple. That's so how is the nth term connected with the n minus 1th? So try to look at two consecutive terms and see what is change that is happening, right? That is what recurrence is all about. Try to see what is the change that is happening from the previous step, or in this case, this previous step, let's say, to go to the next step. That's what you have to ask yourself. What is the change that is happening? Hmm? So, uh, any ideas so far? So what is the change that is happening from 1 to 2 and 2 to 3? What is a common change that is happening? First, you have to maybe see that, right, as a in a non-technical way, just what is the change, and then you try to write it in recurrence. Like in the earlier questions, probably the pattern was easy to see. Here also it is easy. Let's see. So, what is the change that happened from 1 to 2? Well, additively, if I tell you, the most simplest way is think in the addition sense, right? So there is a plus 1, and here there is a plus 2. Here there is a plus 3. Now you think That is a. Oh, sorry. Yeah, that's what's okay. That's what's confusing. As I've written something wrong here. So what have I done? One. Ah, yeah. So that's what is confusing. Sorry. Yeah. So it's just like this. Hmm. So maybe that's why you guys are stuck a little bit, right? I wrote the wrong thing. So now is the pattern clear, right? So it is just a plus. So I mean, at the nth step, you are adding n or n plus one, right? Adding 6, 5. So what should be, what is a of n? How do you get it from an minus 1? How do you get it from the previous term? So what is being added, right? That is how you get. So from the second term you add a 3, from the third term you add a 4. Is that okay? So on the n minus 1th term, what do you add to go to the nth term? So it's it adds, right? We just add n. So there you go. This is slightly different type of recurrence. Earlier we had sort of a number here, but now that is also changing. So it's no more a number. Okay, it's a variable in the sense that it depends on where you are. So this is a simple recurrence. Now maybe for homework, if you already know it, it's good. Find an. But even if you know it, I want you to try to use the recurrence to find an. Find a formula for an, or any ways you want to do it. I don't have any problem. Find a formula for an. So if you know it also, it's fine. You should try to write it and show it to me, maybe on mail or something as usual. Find a formula for, okay. This is one. And then another thing you can try, another similar question you can try is maybe this one. So here the nth term is by the difference of the previous. Now I'm giving you the recurrence and I'm asking questions, okay? So this thing, and let's say that a1 is 1 and a2 is 2. That doesn't matter too much. Okay, this thing. And this kind of recurrence is given, okay? I will just say find the sequence. You can just list the numbers, yeah? Find the sequence. List a few numbers and see some patterns. Find a sequence. Find the sequence. Let me ask this maybe rather than asking find a formula, just ask find a of 100. So you don't expect to find directly a of 100. You would have to see, maybe find till a of 10 or 15, continuing the thing, and somehow you'll see some pattern in the numbers. And you try to see what patterns you can see, if you can use that to find a. Otherwise, you can take 100 steps and find a 100. I don't have a problem. But you would like to do faster than that. You find, so a 100 maybe you cannot find in the beginning. So you find first few terms, it's a 10, 15 terms, and try to see what is happening. Is there some repetition, some pattern? Okay. And maybe so you don't have to prove it. If you prove it, it's better. But finding it is first what I ask. Okay. Yeah. So yeah, maybe that's it for today. We did have some technical issues, which hopefully will not be there for next time. But yeah, this is it for today. Okay. If you have any questions, please ask me. And all right.